Guten Tag to you all! In today's lesson we're going to be answering the question, what do I need to do or think about to stay safe in a car? This is What's Your Question? Let's go! Okay, so I've placed 3 starter questions here for you to have a think about. They are to state a unit's speed can be measured in, to describe how we can measure speed, and explain what safety features there are in a car. Just write down a list of any of those you can think about, throw them in the comments. I'll pause here so you can pause the video and have a go at doing that. Great, so you should have some answers for different units we might measure speed in. The most common one you'll probably come across is miles per hour if you're in England. If for some reason you're watching this in America, you'd be having it in kilometers per hour more commonly. You could also have any unit of distance per any unit of time. So it could be meters per second, it could be kilometers per minute, it could be meters per hour. It could be literally any unit you want to be, as long as it's a unit of distance per unit of time. Second question is, how do you measure the speed of something? You will need to work out how far something has travelled. You'd measure that in whatever unit you want to use. So you'd measure it in meters, and then you can convert it into kilometers, or you could measure it in feet and work it out in miles. It's entirely up to you how you do it. But once you measure the distance, you then need to work out how long it takes to cover that distance, and you then do the distance divided by the time to work out the speed. And finally, some safety features you find in a car. We have got the seat belt, obviously, was the most obvious one, not famous. We have an airbag inside the steering wheel and dotted around the car to make it so if you crash, you are safe. In some cars they have roll cages, so if the car does flip for any reason, you're not going to get crushed. And also things like child locks, so children don't jump out of cars and stuff like that. So if you have any questions about that or any problems, throw the questions about it in the comments. Let's get on with the rest of the lesson. Okay, so I've placed here for you 3 objectives for us to cover in the lesson today. We're going to start off by defining some keywords in the topic. The first one is to define the terms, things like thinking time, thinking distance, braking distance, and stopping distance. The second objective is about categorizing factors as either affecting thinking distance or braking distance, and which ones affect those. We'll also have a look at how they change as you get faster. And finally, we need to research how stopping very quickly, how that can affect the human body, and the reasons why we then need to have specific safety features in our car. Okay, so your first job in today's lesson then is to work out what the definitions for these key terms are. You should be defining what we mean by the stopping distance, the stopping time, thinking distance, the thinking time, and the braking distance and the braking time. You need to write down, or just make sure you know what each of those things are, or try and write down if you already think you know what they are, just to make sure it's in your memory, and I'll tell you what those are afterwards. Right, so the braking distance is how far your car travels when you brake. Not before that, not after that. It's from the moment you press the brakes to the moment you come to a complete stop. It is only that section. Okay, the thinking time is how long it takes, the braking time is how long it takes for your car to come to a complete stop once you've pressed the brakes. The thinking distance is how long it takes for you to consider, not how long it takes, how far you travel when you're considering braking in the first place. So when you immediately notice something in front of you that means you need to brake, and then you move your foot to press the brakes, that time it takes for you to do that is your thinking time, and how far you travel in that time is your thinking distance. In terms of your stopping distance, the stopping distance is the sum of your braking distance and your thinking distance, and your stopping time is the sum of your thinking time and your braking time. They all link together, but those are the definitions for those terms. The next thing I'd like you to do is have a look, or have a think about, when it comes to your thinking distance, what can affect your thinking distance? What can affect how long you take to think about something? Because the longer you take to think about these different things, the further your car's going to travel. So what sort of things might make you think more slowly? What happening in the car might affect the way you think? Throw any ideas for that in the comments, and I'll tell you what those might be in a second. You should also try to think about what sort of things might affect the braking distance or the braking time of your car. Now the thinking is going to be what affects you as a person, and the braking distance will be what affects your car's ability to physically stop itself. You shouldn't get the two mixed up, and you shouldn't mention anything about affecting you when you're talking about braking distances. Pause here so you can have a go at writing or thinking about some things, and you should pause the video here and think about that yourself as well. Okay, so when it comes to your thinking distance, there are a number of different things that can slow your reaction times down. For example, first of all, being drunk whilst you're driving, which people shouldn't be obviously because it's illegal, and also being on drugs while driving. These both can slow your reaction times down and make you take longer to process something. So you'll slow down, you'll take longer to then slow the car, to put your foot on the brakes. We can also include in this you being tired, because if you're tired, you won't be as able to react to things as quickly. Your age also makes you slower at these things. Other people in your car could distract you, so if someone else is talking to you, this can make your reaction time slower as well. Fiddling with things in there like mobile phones and car radios and too many gadgets in your car can also slow your reaction time down. And also sat navs, and also eating or drinking whilst driving can also slow you down when it comes to your reaction time, because any kind of distraction to you as the driver is going to mean you react more slowly. When it comes to your braking distance, we're thinking of things that can affect your brakes or your tyres themselves. So weather conditions, it being wet, being icy, can all affect the brakes, so affect your braking distance. The quality of your tyres can also affect your braking distance. So this is important that you're considering and making sure your car is as good quality as possible. The brakes are in as good condition as they can be, they haven't worn down too much, and your tyres are in good condition as they could possibly be. There are legal limits for your tyres, how thick the tread on them must be, and your brakes can wear down so much that they are not particularly effective anymore. So it is your responsibility to check these things, and if your car is not safe, you can be fined, or even in some cases have your cars towed if it is not safe to drive. I've also placed here a graph that shows you how speeding up affects your thinking and braking distance. You'll notice as we go down the graph, the speeds are bigger, and you should see that if you double the speed in this graph, in fact, before I tell you, if you double the speed, what happens to the thinking distance, and if you double the speed, what happens to the braking distance. See if you can work out a pattern for those things. Just spend a few seconds looking at that graph and thinking. Got it? You should be able to think and see there that if you double the speed, the thinking distance, so how far your car travels whilst you're thinking, will double. But if you double your speed, the braking distance quadruples. So that if you're going twice as quick, you will travel 4 times as far if you are trying to stop. So this means it's really important to make sure that your wheels are as in good condition as possible and your brakes are in as good condition as possible. If you want to work out the distance someone travels while they're thinking, it's fairly simple if you know their speed and their reaction time. Now in the example I'm going to work with, I'm going to use 50 miles per hour as the example speed, and the reaction time is 0.2 seconds, as this is the average reaction time of people, of the average person. So if you're travelling at 50 miles per hour, you first of all need to know, if you want to work out how many metres you've travelled, you'd need to work out how many metres you'd be covering every second at 50 miles per hour. So we do 50 times by the number of metres in a mile, which is 1,609, and we divide that by the number of seconds in an hour, which is 3,600. This gives you 22.3 metres per second, and you then need to multiply that speed by the time it took to think. So if you're travelling at 22.3 metres every second and you take 0.2 seconds to think about it, if you do 22.3 times 0.2, it tells you you should travel 4.5 metres in that time. If we need to calculate a reaction time, we can use this equation. The final velocity squared take the initial velocity squared is the same as 2 times the acceleration times the distance. We can rearrange this equation to make it so the final velocity is what we're trying to work out. So we know what speed the person was travelling at just before they slammed the brakes on. And as long as we know the distance they cover in that, we can also work out the time it took. So we would need to rearrange that so it is, the final velocity is the square root of 2 times the distance, 2 times the acceleration times the distance times the initial velocity squared to get our final velocity. And we can then do the distance divided by the speed to calculate the time it took for that to happen. This should allow you to calculate a reaction time using that. And that's all here on this slide for you to look at. For the final part of today then, you need to have a think about these two questions. What do cars have in them to protect the people in them against hard braking? And what effects can hard braking have on the human body? Pause the video here, have a think about it, write down what you think. So you should have answers to those written somewhere now then. Cars in them have got a number of things. We talked about these at the start of the video. We have got the seat belts, we've got the airbags, and the main reason we have those is to hold you in place when we are slamming the brakes on a car. Because if they weren't there and you slam the brakes on and they weren't holding you in place, you would keep moving at the speed the car is travelling at unless something was put in place to slow you down. The seatbelt specifically holds you in position to slow you down, and airbags are to catch you if the seatbelts can't slow you down enough. If for any reason they didn't catch you, your seatbelt broke or wasn't working, or you weren't wearing a seatbelt, or if the airbag wasn't working, if you weren't wearing a seatbelt, for example, you could be thrown through the windshield, and if you could also smash your face into the steering wheel, and which can be very, very dangerous, obviously, for the human body. And if you're slowing down too quickly as well, which like you can in crashes, you can get things like whiplash, and also in some cases you can cause internal bleeding because your organs, as you stop, are also pushed to the front of your body. And if that happens too quickly, they can pop, they can burst, and particularly your brain, if it spins too quickly or is pushed into your skull too quickly, can shut down and you can pass out, and it can effectively kill you if it happens too quickly. So you really need to make sure that when you're braking, you're doing it as smoothly as possible, wherever you can, because if you brake too quickly, it can have serious negative effects on the human body. Thanks very much for watching. Make sure you stay safe, stay alert, stay curious, and subscribe.